Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. In this video, I'm going to show you how you can make 3D objects interactable. So you can click them like I'm clicking these dice here, or so you can grab them and drag and drop them to other positions. So if that's interesting to you, grab your favorite beverage, pull up a chair and follow along as I teach you how to make 3D objects clickable and draggable in Unity. Before I dive into the implementation, if you want to use these assets that I'm using, this chessboard, these dice, these pieces, I'm using a free asset pack from the Unity Asset Store called PBR Little Games Pack 4K. And it's got a lot of nice models in here like these poker chips, dice, cards, dominoes, jacks, game pieces, and the chessboard, as well as this nice game table. And I'm also packaging up my scripts and my prefabs that I'm using for dragging and dropping and clicking into a nice little Unity package that you can grab from my GitHub repository. I'll put a link in the description. And you can import that into Unity by just going up here and saying Assets, Import Package, Custom Package, selecting that package wherever you downloaded it to, and then clicking Open. Now, I've already imported it, so it says there's nothing to import. All the assets from this package are already in your project. So down to implementation. Under dice here, you can see I've got 5 different dice, and the only difference between these dice are the underlying model. And they've all got this clickable component on them. So this is a class that I created called clickable. Another prerequisite is you're going to make sure that you have a collider. All right. And in this case, I've also got a rigid body because I want to interact with physics. I want to be able to throw the dice. I want them to hit the board and bounce and stuff like that. But the important thing is that you've got a collider and you're going to want to have the clickable script. And then what you do with that click event is up to you. So in this case, I've got a dice roller that is going to grab that clickable component and determine if it was clicked or not. I'll cover that later. In fact, I covered this in detail in my previous video I put up, how to create rollable dice in Unity. So another important thing, the way I'm implementing this, you'll notice there's this raycast layer mask, which is currently set to dice. And you can see that all of these dice are assigned to the dice layer. So I created a layer here called dice. And if we go into our physics settings, so I'm going to go into project settings, physics, scroll down here and look at our collision matrix, you can see dice collide with the border and they collide with dice. And also, let's see, board also collides with dice. So essentially, the only thing that's going to register a collision with dice is the board, the borders, and other dice. So I do that so if I roll them and they hit another dice, the other dice gets knocked around. So the important thing is it's on its own layer, and then I can specify in my clickable script for my raycast, I only want to hit dice. So let's look at how that works. So in my clickable script, I have a serialized field for the raycast layer mask and a raycast distance. And I like to make my serialized field an actual layer mask instead of just an integer. I've seen some people just use integers. And the reason I do that is because I can actually just pick my layer mask right from here. And then I can pass that directly into the raycast. So right here, I just pass that raycast layer mask right into my physics.raycast method. So I'm building a ray using the camera screen point array, and I'm giving it our mouse position. Now I should point out that this mouse input, this is from a class I created called mouse input base. And by default, this class is using the old Unity input system. So I'm just returning input.mouse position. Get mouse button down will return input.get mouse button down for whatever button. And the same thing for get mouse button up. Now you can override that base class if you want to use the new Unity input system, and I'll demonstrate how to do that later on in the video. So basically, this guy will grab whatever mouse input base happens to be assigned to this component, and if you haven't added one, I'm just going to arbitrarily add the base class, so it will use the old input system. So in here, I'm grabbing the mouse position from that mouse input, passing it into this physics.raycast. I'm using that ray, I'm using the raycast distance, raycast layer mask, and then it's going to return any hits we get into hit info. Now, if we don't hit anything, then I check to see, have I set the isMouseOver flag to true? In other words, has the mouse entered this object before? If it hasn't, I'm just going to return and do nothing. But if it did think we were over this and now we're not anymore, then I want to call this handle mouse exit. And if you look at handle mouse exit, I set my isMouseOver flag to false and I fire the on mouse exit event and I pass in our game object. So this is what you're no longer over. We have left this object. All right. Now, on the other hand, if we did hit something, then I want to check and see, is the thing that we hit us? So I'm checking the game object on the collider to see if it's us. Now, this should always be true, but it might not. So in the case that it is not true, then again, that means we're no longer over us. And so I want to check and say, well, if we already thought we weren't over us, just return and do nothing. Otherwise, just like up here, call handle mouse exit. On the other hand, we want to say that we did hit something and it was us. That means we're now over us. If we already thought we were over us, just return and don't do anything. Otherwise, handle mouse entered. Handle mouse entered is just going to set isMouseOver to true and fire the on mouse entered event. So the other thing that we check in here is mouse up and mouse down. And this is just going to go to that mouse input base, which might also be an overridden class using the new Unity input system. And I'm basically checking to see, is mouse button down true? And actually, this is checking to see if the mouse button was down this frame. So it's not if you're holding the mouse button down. We're just checking to see, did you press the mouse button this frame? If you didn't, I'm just going to return and do nothing. All right. Otherwise, if you're not over us, then just return and do nothing, because that means you're clicking, but you're not clicking on us. Otherwise, let's fire the on mouse down event, passing in our game object. And likewise, exact opposite for mouse up. If we didn't release the mouse button this frame, return and do nothing. If you released it but you're not over us, just return and do nothing. Otherwise, fire the on mouse up event, passing in this game object. So that is it for the clickable event. And you can see how I implemented that using the dice roller. All right. So one of the things I do in the dice roller awake method is I grab the clickable component and I subscribe to the on click event on that clickable component. And in on click, I just call roll die. And I'm not going to go into detail about all this because I covered this in my how to make rollable dice in Unity. I just want to show you how you can subscribe to the clickable events and use them for whatever you want in your game. So now that we've covered clickable, let's look at draggable. So I'm going to collapse these dice and let's expand this rank here. So this is the rank 0, the first rank, and then these are files. So every rank, there's 8 of them, has 8 files, but only rank 0, or the first rank, has any files that actually contain anything. If we go and look at these other files, they're all empty. But each of these files has a white rook. Now, I could have made these actual correct chess pieces, so rook and knight and bishop and queen and king and so forth, but just for the sake of simplicity, I just made them all rooks. So each of these guys is draggable, right? Nothing else on this board is draggable. And just like the clickables, you need to have some kind of collider on your draggable objects, and you want them to be on a layer because just like clickable, I want to have a raycast layer mask. In fact, I want to show you that draggable derives from clickable. So I'm basically just extending clickable to make it draggable, and I'm adding things that are specific to drag and drop. So this is an example of using inheritance. Often in Unity, I prefer to use composition over inheritance, but this is a great example of where inheritance actually makes sense. If you have common shared functionality that's shared across multiple components, that is a perfect example of where you want to use inheritance. But I'm also using lots of composition in this project, which you'll see as we go on. But jumping back out into the Unity editor, let's continue to look at this game object here. So our rook, we have our model. It's got an LOD group, which you don't need to worry about. I have a collider. The chess piece basically has things that are specific to the type of piece, the piece color, the rank. You don't need to worry about that. That would be pertinent if this was a chess game. Now the draggable script, what we inherit from clickable are a raycast layer and raycast distance. What we extend to this and add to it is a drop target layer mask. If you're dragging an object, you intend to drop it somewhere, you only want to drop it on legal drop targets. So let's look at all these files. All right. So all of these files they're just chessboard squares, right? So how do we handle legal drops? So think about that for a second and ask yourself, how do I determine where I can drop a piece? I want you to look at this layer here. This layer is a board tile, right? And if we go back and look at our white rook and we look at our draggable script, drop target layer mask, board tile. Okay, so if we go and look at our draggable script, and we look at update, first I call the base class update, and that's going to determine if the mouse is over, the mouse is pressed, and so forth. But then we're going to check and see, are we dragging? If we're not, we don't need to do anything. All right. Now, otherwise, we want to get the mouse's position, and we want to compare it to the last mouse position. So I have a private variable here called last mouse position. And whenever we move the mouse, we save that position off to last mouse position. Okay, so we want to determine if we are over a drop target. So I've added this method called detect drop target. And if you're not familiar with this syntax, this is what's called a tuple. So this method here, detect drop target, is returning a tuple that's going to be a game object and a vector 3. A game object called target object, and a vector 3 called hit point. And so I'm doing another raycast to the mouse's position from this camera screen point. And for my layer mask, I'm using the drop target layer mask, which we set in the inspector to board tile. All right. Now, if we did not hit anything, I'm going to return null, and I'm just going to return positive infinity for the hit point. So drop target will be null, hit point will be positive infinity. Whatever we got for drop target, I'm going to assign it to this property, drop target. So that's a public property with a public getter and a private setter. And I'm going to fire on dragged. And I'm going to pass in us. I'm going to pass in the hit point where we hit the drop target. And I'm going to pass in whatever our drop target is. So anybody subscribing to the drag events for this object will get notified that, hey, this object is being dragged. All right, now we need to handle mouse down and mouse up. So in our wake method, we subscribe to handle mouse down and handle mouse up. All right. So on mouse down and on mouse up, that's coming from our base class of the clickable event. So we basically want to know if the mouse bus was pressed or released. And we're just going to our new handle mouse down, handle mouse up events. So what are we doing in handle mouse down? First, we check to see if we're dragging. If we're already dragging, just return, don't do anything. Otherwise, set dragging to true and fire the on drag start event passing in our game object. Likewise, if they release the mouse, if we weren't dragging, just return. Otherwise, since we were dragging, we want to set is dragging to false And we want to call this detect drop target. So this is going to get the new drop target. And we're going to call on drag end, passing in us and then drop target. So this probably isn't strictly necessary, but we want to let them know that this object is no longer being dragged. So that's how I implemented draggable. So the next thing to look at is to show you how we're using draggable so that we can pick up those chess pieces, move them, and drop them on their destination tiles. All right, so we have an object that we can drag. What can we do with it? How do we utilize that draggable class? So again, looking at our white rook here, you've got draggable here. Fine, we looked at that. Let me turn my dice off since they're kind of cluttering up the board and I don't want to see them and have to deal with them. What can we do with this rook? Well, one thing I wanted to do is whenever I hover over it, if you remember, there was some visual indication when the mouse moves over it and moves off of it, right? So it's always good to give your users some feedback to let them know, hey, this is something I can interact with. So I had this hover indicator. Now I mentioned I was using inheritance and how generally I prefer composition over inheritance, especially when using a composition-based engine like Unity, where everything is a component. I mean, think about it. This is a component, right? This is a component. This is a component. All of these things are components. So instead of making draggable worry about displaying some kind of visual feedback when you hover over it, I just made a hover indicator component. The only thing it cares about is showing visual feedback when you hover over it. Draggable doesn't need to worry about that. Clickable doesn't need to worry about that. So we've got this nice little single responsibility component called hover indicator, which has a single serialized field called hover scale. And so as you can probably imagine, all I'm doing is when the mouse enters here, I'm going to change our local scale to hover scale. And when the mouse leaves, I'm going to set it back to vector 3.1. Now, in this case, because I know that these chess pieces by default are a local scale of 1, I can do this. I can just hard code vector 3.1. If maybe your pieces could have a variable size in your game, then what I would probably do here is save off the initial scale and then reset this back to that initial scale when the mouse exits. So that's how I do the visual feedback that you're hovering over it and moving off of it. Okay, the other thing I want to do is I want to be able to tell where I can drag this thing to. Oh, but before that, you'll see there's this drag indicator script. So I'm going to run this again. I want you to watch what happens when I actually pick up the chess piece. All right, so you see that it gets bigger when I move over it. Well, watch what happens when I click it. You can see it's up off the board. It's hovering over the board now. And then when I drop it, I put it back down. All right, so that is all being done by that drag indicator component. So once again, composition over inheritance. I have this drag indicator, and it's got a single serialized field called drag offset, which is just 0.1 up in the y-axis. So what do? On drag start, I just set my drag offset. I add that to our position. So pretty simple. And on disable, I unsubscribe from that on drag start. I'm actually resetting it back to its initial position when I place it because there's already logic in another component called move handler that I actually handle where I drop it to a destination object, and I will actually update its position when it's dropped. So it made absolute sense to keep that logic in here because I'm actually moving it from one place to another. In other words, I'm changing its position in here anyway, so it made sense to do that here. Now, I want you to pay attention to something else in here. I left this commented code here intentionally because I wanted to show you how often when you're developing a game, you will first get your game to work, and then you will go back and refactor it to make it clean, to adhere to solid principles and have clean code. So initially, I had code in here to display that drop indicator prefab, to do the drag offset and all that stuff. It was all in this move handler. All this stuff was in this move handler. All that extra code. Now that violates the single responsibility pattern. So after I got it all working and I knew that this design was sound and that it worked, I refactored this and I extracted the stuff out into their own separate components and basically was able to trim the code in this class down significantly. I probably cut it in half if we were to go ahead and get rid of all these commented lines. So I will go ahead and get rid of these commented lines at some point, but I just wanted to show you that commented code. I left that in there on purpose just so I could talk about that. So now I want to talk about the move handler. So all of this stuff here, I got my hover indicator, my drag indicator, I got my move input base. What do we want to do when we're actually moving stuff? Well, the move handler, it actually lives up here on the table, but underneath of that on this chessboard, I've got a drag and drop handler, and I gave it a collection of draggables. So those are all my rooks. Those are all the pieces that I can actually move. Now I put these in the inspector and I made them serialized fields. Another way to do this would be to go and look for anything that has that draggable script on it. You could do, like in your awake method, you could do find component by type. I just decided I wanted to add these in the inspector. If you're working with the designer, they might prefer that to have a little bit more control over this. If we look at my drag and drop manager script, you'll again see some commented code. Like when I was scaling the piece up, when I was dragging it, I was doing that in this drag and drop manager. That's been extracted out into its own separate component. But this drag and drop manager is going to pass on some of the events from that draggable class. Basically drag start, drag in, and on drag. So this is sort of a middleman between all of those individual draggable components and anything that might want to respond to things being dragged and dropped. So basically this guy in Awake is going to iterate through all of his draggables, going to subscribe to those events, and we're going to activate that draggable object so it can be dragged. And in on disable, we're just going to undo all that. So in handle mouse entered, which is called from handle mouse entered, from on mouse entered event that we're subscribing to from the clickable base class on that draggable, we're just going to set is dragging. Actually, we're not doing anything in here. That's all handled by that draggable base class. We're not doing anything in here. So I can probably unsubscribe from these events. So what I was doing in here is doing the scale for when you pick it up and when you set it down. And that was the only thing I was doing in here. So yeah, I can clean this code up. I missed that. You get to witness a little bit about how the sausage is made. Clean that code up a little bit more. All right, so let's ignore that. Forget I said that. Handle drag start. So when we start dragging, if we're already dragging, return. Otherwise, I basically want to deactivate everything else that can be dragged. Now, why am I doing that? If I go back to Unity, and it's going to have to recompile because I edited that script. There was a bug when I first implemented this, where if I was dragging an object and I dragged it over top of another draggable object, it would pick that object up and drag it too. So right now, I can drag over those other guys and it's not trying to drag them as well. So that little check that I was just showing you, that's what that's doing. All right. So if I'm already dragging, just return. Otherwise, we want to go in and we want to deactivate all of those other objects so I can't try to drag them. Now, I want to set our dragged object variable to be whatever dragged object was passed in from that event. And I want to refire our own on drag start event, passing in that dragged object. Now, if we're dragging an object and the mouse moves, we're going to handle that too, but only if we are dragging. If we're not dragging, we never should have got called here. I probably should have missed some kind of an error or a warning in that case, but I'm just going to ignore that, do nothing. I'm just going to fire on drag and pass in those parameters. Just basically being a middleman, a broker, if you will, for that event from the draggable object. And handle dragged end. If we're not dragging, do nothing. Otherwise, go set all the draggables to true and fire our on drag end so that whatever was subscribing to us knows, hey, we stopped dragging that object. So now this is where we go back up here to the games table and we look at this move handler. So the move handler, what are we going to do in here? Well, for one thing, we need a drag and drop manager to subscribe to. And so once again, I'm assigning this in the inspector. I could do a find object of type and grab the drag and drop manager that way. But again, if you're working with a designer, they might prefer to be able to drag and drop it in the inspector. Either way, you are basically injecting that thing. So let's look at the move handler. Again, you see there's that commented code that I moved out of here. We've got our drag and drop manager. We subscribe to the events and start. We unsubscribe and on disable. So on our handle drag start event, we basically want to get the transform from the object that we're dragging. And I want to save off the start position where we started dragging it from. And this is so if we drop it and it's not on a valid drop target, we can put it back to where we got it. And then we are going to move its parent. We're going to save off its start parent because we want to reparent it back to the object we grabbed it off of. So initially it was on a rank and file. It was on some file position. When we pick it up, we're taking it off of that position. And when we drop it, we want to put it on another one or put it back where we got it from. So here we're setting its position, its parent to null. So the object that we are dragging, we're taking its transform, we're setting it to null. So it no longer has a parent. It is essentially an orphan. Now, when we drag that object, we're going to set its position to be whatever position was passed in from that handle drag. And that's basically getting that from our mouse position. And then we are going to translate that guy up by 0.1. That's basically our hover. So when we started dragging an object, you remember we picked it up? Well, we want to maintain that elevation as we move it. That's all that we're doing here. All this code I can delete because that was where I was displaying a drop indicator, which I don't need to do anymore because that's now its own separate component. I got to show you that component, by the way, because I don't think I've demonstrated that yet. Handle drag in if we have stopped dragging. If we don't have a drop target, we're going to put it back where we got it from. Otherwise, we're going to give it the new parent and set its position to its start position, which should be vector 3.1 or vector 3.0, most likely. All right, let me go back and show you that drop indicator. So if I go and run this, let it recompile because I edited that script again. When I drag over a new target, you see it displays a drop indicator. It's to let me know, hey, you can drop that piece here. Now, I'm not putting in any logic to see if this is a valid place to drop it. If it's a legal drop, all I'm doing is looking for a drop indicator, or a drop target, I should say. So you remember the drop targets. I'm basically using board tile for that. And we go up here, and you see this drop target indicator script. So that is on this games table, and it is subscribing to the same drag and drop manager that the move handler is subscribing to. I basically just dragged chessboard right onto there. And since chessboard has a drag and drop manager, our drop target indicator also has that same drag and drop manager. So in there, I just want to subscribe to handle dragged, to drag and to on dragged and on drag in. And this is handle dragged, handle drag in. Okay, so I've got two methods in here that are basically what I'm doing to handle those subscriptions. So what do I want to do in there? Well, if I'm dragging and I don't currently have a drop target and I had a drop indicator, I want to despawn that drop indicator. So if I did have a drop indicator being displayed, but I'm no longer over a valid drop target, then I want to just get rid of that drop indicator. And I'm using my object pool manager, which is a free asset on the Unity Asset Store. I will put a link in the description, but it will also be in that bundled package that I put up on my GitHub project for this tutorial. And you can just grab that project if you want to. And you'll get the object pool manager as part of that package. On the other hand, if I didn't have a drop indicator, then I want to spawn a new one. And I want to spawn it over the drop target. So let's look at the spawn drop target indicator function that I'm calling here. I'm going to spawn a new drop indicator prefab using my object pool manager. So if I already had one in the pool, I'm just going to grab it. Otherwise, I'm just going to instantiate a new one. I'm going to set its parent to be the drop target's transform. I am going to activate it so that it's visible, and I'm going to set its position to vector 3.0. Since I know that that will let it render on top of that position. If the target indicator moves, which will be called by handle drag end, then I just want to set it to its new parent and set its position to vector 3.0. If you stop dragging, if I didn't have a drop indicator, just return and do nothing. Otherwise, I want to despawn our drop indicator and set that value to null. All right, so this is going to add it back to the pool so that I can reuse it the next time I want to spawn a drop indicator. And I might as well go and show you what the drop indicator looks like. So all it is a cube with a custom material that I created called drop indicator material. Now I'm using the URP, the Universal Render Pipeline. You might have to change this material if you import this package into a product that's not URP. You're going to have to fix this material. But basically, I just created a metallic opaque lit material, and I gave it an emission. So I set its base color to be this light blue, and I set some emission to be this light blue as well, which I think looks pretty cool, just to give you a nice little indicator that you're dragging over a legal target. Okay, as promised, I'm going to show you how this can be modified to work with the new Unity input system. And it honestly couldn't be simpler. So basically, if we go to any of our objects, either our draggable objects or our clickable objects, and you can see that I replaced that mouse input base with new mouse input. If we double click on that, you can see that it derives or extends mouse input base. And I'm just overriding those base class functions. So now mouse position now returns mouse.current position read value. By the way, if you're not familiar with the new Unity input system, this is sort of a easy mode or shorthand way to use this. It's just as simple as the old Unity input system was. Actually, I've been corrected by a guy named Cyber Angel that the old system is not a system, it's the Unity input manager. The new one is the Unity input system. So I just want to be grammatically correct there. And then for these guys, get mouse button down and get mouse button up. Depending on which button I'm asking for, I just return current left button was pressed this frame, or current right button was pressed this frame, or was released this frame. So that is it. All I had to do is extend mouse input base and override these functions. And then in the Unity editor, just replace mouse input base with new mouse input. And you can see that I do that on all of these rooks as well. And the really cool thing is in clickable, which is the base class, of course, that draggable extends, I am just getting in my awake method, where are we doing that? We're getting mouse input base. So it's going to get any class that's attached to this component that extends mouse input base. So I can't imagine anything that would be any simpler than that. Well, I think that about wraps it up for this video. If you found that useful, and I really hope you did, do me a favor and click that like and subscribe button. And while you're at it, click that notification bell too, so you can be notified the next time I post a video. Be sure to go to my Steam page if you haven't already and wishlist my upcoming real-time cross-platform multiplayer card game Highland Panic that I'm hoping to release sometime in early October. Also, check the links in the description if you want to grab any of those assets. And let me know what you would like to see in upcoming videos. I am planning on making a video where I show you how you can use mathematical functions in the inspector to arrange things in your scene. So in this particular tutorial, the way I arrange those rooks and all those drop targets and things, I actually use some really cool mathematical functions right in the inspector to evenly distribute them. You can also use things like sine and cosine in there to like create a perfect circle or waveforms or whatever. And I will definitely get that in my next video. And I'm hoping to, sometime not too long from now, release a complete multiplayer tutorial on how to make the board game Ludo from scratch in Unity. So, thanks so much for watching and good luck on your game development journey.